Welcome back to the Lane Water Cafe. Today in the cafe we're going to be talking about the power generation industry. More specifically, we're going to be talking about some key design considerations you'll want to account for when designing, purchasing, and installing your next large-scale reverse osmosis system at your power generation facility. I'm going to start with some pretty basic stuff here, but it is certainly very important. Key design consideration number one is to make sure you have a clear understanding as to the purity and the quantity of water that you need your reverse osmosis system to produce. Now, in a power generation facility, it's pretty safe to say that the most popular use of reverse osmosis is for boiler water feed water treatment. And if you just consider that simple example, and you look at your reverse osmosis system as really being the heart of that overall boiler feed water system, you begin to have an appreciation for why it's so important that you understand exactly what type of output you want in terms of quality and quantity. Certainly one thing that comes to mind is the outlet quantity and quality of your reverse osmosis system directly impacts the design and the capabilities you'll need on your polishing demineralizer, which will be the next step in the process, because boiler feed water, especially for high pressure boilers, requires a much higher quality than what a reverse osmosis system can provide. Something else to consider right up front is what type of redundancy do you need in that system? Do you have the ability to stockpile reverse osmosis water in a large tank? Or do you have to have 100% availability, 95% availability? What's that look like? Because reverse osmosis systems do require system maintenance. You'll have to take elements, perhaps passes, perhaps stages, out of service from time to time for cleaning and maintenance. And you want to have all that accounted for right up front. Now, the second consideration I want you to think about is this. Are we really looking at the reverse osmosis system where the priority is cleanliness of the water, the quality of the water, quality of the permeate? Is that the number one consideration, maximizing that? Or is it minimizing the amount of wastewater that is produced? Depending upon which one is your priority will really drive your design. If you're looking to maximize the use of water and maximize permeate quality, you'll be looking at increasing the number of passes in your design. Conversely, if your number one priority is minimizing wastewater, well then you'll be looking at maximizing the number of stages that you'll have in your reverse osmosis system. And we've got a couple good process diagrams here that kind of show you the difference between a pass and a stage. Clear that up for you. Key design consideration number three, understanding how variable the water coming into reverse osmosis is in terms of quality. I'll give you a couple examples. Think about, can your reverse osmosis system handle a widely variable inlet? Is the water stream coming into it widely variable? If you can't handle it, what are you going to do in terms of pre-treatment again, up ahead of the reverse osmosis system? What's that going to look like? On the outlet side, remember, reverse osmosis system works by concentrating one of the streams. We call that the reject stream. And you need to make certain that under all conditions, let's just say in summertime drought conditions, that you can indeed discharge that high conductivity water that's going to be what we term the reject that's coming off the reverse osmosis system. We have seen cases where people have run into problems with their discharge permits because they hadn't accounted for the fact that under drought conditions the receiving stream flow is already reduced, and now you're trying to add a very high dissolved solid water into there, and you might find yourself in a very unfortunate situation. So those are a couple other things to consider right up front. Key design consideration number four, Are you using a surface water? And if you are, have you monitored the quality of that surface water across multiple seasons and across multiple years? And have you, in your design, accounted for the issue of turnover? When water passes through that maximum density point and the lake or river turns over, which means that the water on the top of the body of water heads to the bottom and vice versa, typically a very high week or so of turbidity. And if you haven't accounted for it, you are going to be in for a world of surprise and hurt as your RO system begins to foul. So that is something you absolutely have to account for. In a similar situation, if you're using a well water, this is design consideration number 5, here you have a situation where total suspended solids, TSS, is probably pretty stable under all conditions because it is not a surface water, you're pulling it from a well. However, total dissolved solids, even in a well, can vary wildly from season to season and year to year. So do you have enough of a baseline to feel confident that the reverse osmosis design and its associated pre-treatment and post-treatment, that combination is sufficient to be able to handle all of the varying water conditions that your plant may see? So I know we kind of rushed through these things. That's 5 of the 11 parameters that we discuss in gory detail in the free white paper that you can download right here off this page. So I encourage you to do that. And I'd also like you to think about a few things when it comes to Lane. Why would you choose Lane Christensen for your power generation water treatment needs? Really 4 things I want you to consider. One is the ability to complete the project from wellhead all the way through to process output. Very few companies can bring you the total package, total turnkey operation. Second is going back even ahead of drilling, is the hydrology research to identify new water sources, alternative water sources that can keep your plant running when others perhaps are gasping because there's not enough water nearby. Third, going back to the well drilling and having a team of experts on hand that can sink wells and well fields to make sure that your process needs are met no matter what the conditions. Finally, of course, once you sink a well, you got to get that water out and you have to get it to the plant. Having a company on your side that has the experience to transport water via pipeline, create those pipelines, maintain those pipelines, can sure be a big help. So 4 quick reasons why you might choose Lane. Thanks again for joining us at the cafe. We look forward to catching you next time. Bye now.